Hello everyone, in this video we will review for test 1. Starting with the first problem, we want to find the slope of a line that passes through these points. You want to take each point and label your x and y coordinates. So our first point we're labeling as x sub 1, y sub 1, and our second point we're labeling as x sub 2, y sub 2. Now we'll take those values and substitute them into the slope formula. So y sub 1 minus, or y sub 2 minus y sub 1 in the numerator divided by x sub 2 minus x sub 1 in the denominator. We'll substitute those values. In our numerator, we'll have 12 minus 7. And 12 minus 7 gives us 5. In the denominator, we'll have negative 5 minus negative 3. And negative 5 minus negative 3, that gives us negative 2. Remember, minus minus, that becomes addition. Now we'll simplify this as negative 5 halves. For the second problem, we're asked to divide, so we'll divide 4.2 by 2. That'll give us 2.1. And now with our exponent, we have 10 to the 7th divided by 10 to the negative second power. So we'll keep that base of 10 and subtract the powers. 7 minus negative 2. Okay, we'll write that as 2.1 times 10 to the 9th power. 7 minus negative 2, remember that becomes addition. Now our second part of the question tells us to write our answer in standard notation. That means take it out of scientific notation. So it's 2.1. We have to move our decimal point 9 spaces to the right. One, two, three, 4, 5, 6, 7, 8, 9. You should wind up with 8 zeros. Okay. Now the next example, if f of x equals x squared plus 12x minus 7, we want to find f of negative 3. So everywhere x is, we're going to replace negative 3. So f of negative 3 equals negative 3 squared plus 12 times negative 3 minus 7. All right, so we want to continue to simplify here. Negative 3 squared is 9, and 12 times negative 3, that'll become negative 36, minus 36, minus the 7. When we combine these terms, 9 minus 36 minus 7, we'll get negative 34. Now, number 4, is this a function? We want to perform the vertical line test. So each of these vertical lines, we're checking to see if they touch the graph only once. If they do, then it is a function. If they do not, it's not a function. And as we can see, these vertical lines touch the graph twice, which means this is not a function. Number 5, draw a line that does not have a slope. And the line that doesn't have a slope is any vertical line. So you just draw a vertical line. That's an example of one that has no slope. Number 6, write an equation of the horizontal line that passes through this ordered pair. We have 8 on the x-axis, negative 4 on the y-axis. So if we're at negative or positive 8 on the x-axis and then down to negative 4, we should be in the 4th quadrant. What is the horizontal line? So we think about the two lines that intersect to form this point. We have a a vertical line that moves up and down, and a horizontal line. So where are we on the horizontal line? We're at that space on the y-axis, which in this case is -4. The equation of the line should be y equals -4. So the horizontal line that cuts through this point 8, -4 should be -4. Let's rewrite that, -4. Y equals -4. Now simplify. Negative or 2/5 raised to the -2nd power. First of all, we know we need to make this power positive. We eventually will have to distribute the term, so let's go ahead and do that first. Distribute that power. So we'll get 2 to the -2nd power divided by 5 to the -2nd power. Now let's change our powers to positive. To make the negative power that's in the denominator positive, we'll move it to the numerator. To make the negative power that's in the numerator positive, we'll move it to the denominator. So that will become 5 squared in the numerator and 2 squared in the denominator, which we can simplify even further. 5 squared, 5 times 5 gives us 25, and 2 squared, or 2 times 2, gives us 4. So 25/4. For number 8, we're asked to simplify. We have x times y to the 3rd power, and then in the denominator x to the -5th power times y to the 8th. We're going to go ahead and combine these like terms. So see our first term, the x, that's x to the 1st power, divided by x to the -5th power. And then our y terms, we have y to the 3rd power in the numerator, and the denominator, y to the 8th power. Now when we combine these terms, we're going to subtract the powers. So 1 minus -5. Our power minus -5. And then our y term, 3 minus 8. Now 1 minus -5, that's 1 plus 5. That will become x to the 6th power. And then with our y term, we have 3 minus 8. That will become -5, which we know we can't have a negative power. So we need to make this positive by moving it to the denominator. So that x to the 6th power stays in the numerator, x to the 6th, divided by, now we're moving the y term to the denominator so that we can make our power positive. So here's our final answer, x to the 6th divided by y to the 5th. Next, we're going to state the domain of this graph. Domain, remember, is the x coordinates, or in this case, what is the range of our x values? So how far over do we move on the x-axis? What's that range of values, potential values? Now, it looks like this is at the 2nd tick mark, right? And it's an open circle. So the value of x cannot be 2, but it could be numbers that are in the range above 2, so 3, 4, and 5. So we would say x could be numbers that are greater than 2, right? Greater than 2, but they are less than 5. So you don't go over 5. So somewhere in this range between 2 and 5. X is between the range of 2 and 5. Now, x cannot be 2 because we have the open circle, but look at 5, we have a closed circle. So that means x can also be 2, or be 5, excuse me. So we have 2 could be, 2 is greater than 2, but it could be equal to or less than 5 because of our closed circle. Now look at number 10. All right, find the volume of a cube whose edges has the length 5 ABC. So remember, a cube is a three-dimensional shape, but it has equivalent sides. So all of the length, width, and height are the same. And you're given the value, which is 5ABC. To find the volume of a cube, you would just multiply the length times the width times the height. Or because the height, the length, and the width are all the same, it's equivalent to whatever that length of the side is to the third power. And that's what we're going to do. We're going to take the length of the side, 5ABC, and we want to raise that term to the third power. So that means distributing the 3. 5 to the third power, A to the third power, B and C to the third power. Now 5 to the third power will get 125. And behind it we'll write A cubed, B cubed, and C cubed. And that's our answer. Number 11, state the formula for the circumference of a circle. And for the circumference of the circle, you have two options. You can multiply pi times the diameter, so pi times d, or 2 times pi times radius, or r. So both of these forms would work for the circumference. Formula of a circle. Next, we're finding f of 0. Look at our graph. When we are at 0 on the x-axis, what is the value of the function? Where is the graph? When we're here at x, at 0, where is our graph? Let's look up to find where our graph crosses this point. Right here. And that's 1, 2, 3, 4. So f of 0 is 4. Next, write point 0.0000074 in scientific notation. So we need to move this decimal point behind a single digit number, one that's greater than 0 but smaller than 10. So we're going to count over 1, 2, 3, 4, 5, 6, 7 spaces. Right between the 7 and 4. That's 7.4. And because we moved 7 spaces to the right, it'll be x to the negative 7th power. Next, we're evaluating the square root of 4 to the 2nd power plus 3 to the 2nd power. Now, what is 4 to the 2nd power? That's just 4 times 4, or 16. 3 to the 2nd power, that would be 3 times 3, or 9. So underneath our square root, we have 16 plus 9. When we add those two numbers, we'll get 25. And we know the square root of 25 is 5. That's our answer for that one. Now let's look at number 15. If h of x equals the cubed root of x minus 7, find h of negative 8. So here we're substituting negative 8 everywhere we see x. So h of negative 8 equals the cubed root of 8 and then minus the 7. Now when we look to find the value of 3 to the 8th, or the third root, the cubed root of 8, what is our cubed root of 8? That's 2. And you can just punch that into your calculator. You're being asked, what number do you multiply by itself 3 times in order to get 8? And that's 2. 2 times 2 times 2 is 8. So 2 minus 7 can be simplified further. 2 minus 7 would give us negative 5. All right. Now I see a minus here in our function. We needed to add a minus into our cubed root. So that should have been a negative 8 right here. So what that does is changes the sign. The cubed root of negative 8 is actually negative 2. So when simplifying here, we have -2 minus 7, which gives us -9. So watch that sign. Make sure that you add your negative underneath the cube root. Let's look at number 16. Suppose f of x equals 9 minus 15x. Is this a linear function? Now, can this be written in that slope-intercept form? When we have an equation, we can look to see if the equation can be written in a linear form, which we know slope-intercept form is. So can I write this as y equals mx plus b, or f of x equals mx plus b? Do I have some number times x plus or minus another number? And we do. It's just in different order. We can switch the order here. We can move that -15x in front. That'll become -15x. And then the 9 we put behind, so plus 9. So is this linear? Yes, it can be written in linear form. Now, what is our A and what is our B? Now, when we're thinking about A and B, we're thinking about that function form, all right, our A and our B. First term, second term, our A in this case would be -15, make sure you keep the sign, and our B would be 9. All right, let's look at number 17. Which equation best models the data in the table? Look at our data in the table. And something that stands out should be the 0. When we have 0 for an x coordinate, we know that that y value is going to be the y-intercept or the b. So we know the y-intercept in this case is -2. If we were to substitute these values into the slope-intercept form of an equation. We also know that if we have more than one point, we can find our slope using our slope formula. That y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So that's what we're going to do here. We've already got our y-intercept. We'll substitute 2 of the points. It doesn't matter which one. Let's use the second and third point and find our slope. So the second and third points, we have 0, -2. We'll go ahead and make this our first point. So that will be x sub 1, y sub 1. And then the second point, 2, 4, we would label as x sub 2, y sub 2. And now substitute these values into our slope formula. Y2 minus y1, 4 minus -2 in the numerator. In the denominator, x2 minus x1, 2 minus 0. Okay, we can simplify here. That 4 minus -2, remember that becomes addition. So 4 plus 2 would be 6 in the numerator. And 2 minus 0 is just 2 in the denominator, which can be simplified further, right? Because 6 divided by 2 gives us 3. So that's our slope. We can plug that into our slope form of the equation. Y equals our slope, which is m, so it'll be 3x. Our y-intercept was -2. So we're looking for potentially this form of the equation, which we see as letter D. That's our correct answer. For number 18, simplify. This is x to the -4th power cubed. So that's x to the -4 times 3 gives us -12. And then y to the 8 times 3, or the 24th power. Now, the only other thing we need to do here is make our negative power positive. So we'll move it to the denominator. That's y to the 24th power stays in the numerator, divided by x to the positive 12th power. This is our answer. For number 19, we're asked to state the range. Range is going to be the interval along the y-axis for this graph. What are potential values for this range? As we can see, this arrow moves upward, so it could be any number that's above this space. So where are we on the y-axis at this point? We're 1, 2, 3, 4, 5, we're -5. So our y value could be any number that's bigger than, it goes up, greater than or equal to -5. And for number 20, we're just simplifying here, understanding -5 squared. That minus sign stays. And then 5 to the second power, 5 to the second power gives us 25. And now letter B, anything raised to the power of 0. We have 8 to the power of 0. Any number raised to the power of 0 is 1. So this one would be 1. Letter C, state the formula to find the area of a circle. The formula to find the area of a circle is pi r squared. Letter D, if f of x equals the absolute value of 2x minus 7, we want to find f of -10. So everywhere x is, we're going to place -10. All right, so 12 times -10, we want to simplify here first. Or is that's a 2, not a 12. So 2 times -10, that gives us -20. Minus the 7, that becomes the absolute value of -27. Remember, absolute value measures distance from 0. So how far are you from 0 when you are at -27? You're 27 spaces away. That's the absolute value, 27. For number 21, you're asked to sketch the function f of x equals -3x plus 4. So we're going to create a table, one column for the x coordinates, one column for the y coordinates, and we're just going to substitute the points 0 and 1 into our function. So when x is 0, we have 3 times 0 plus 4. So your y value would be 4. When x is 1, we have -3 times 1, that gives us -3 plus 4. And -3 plus 4 gives us 1. So here's two ordered pairs that we want to plot. Connect those 2 points to graph the line. First, 0, 4. 0, and then 4 on the y-axis. 1, 2, 3, 4 will be here. And then 1, 1. So 1 on the x-axis up to 1 on the y-axis. We'll connect these 2 points to create the graph. Number 22, we're sketching a graph again, but notice we have a power, x to the second power. So that means we should have that parabola shape. But let's substitute values into a coordinate or ordered pairs again. We just need to make sure that we get points on both sides of the y-axis. So we need to substitute not only positive x coordinates, but negative x coordinates as well. So we'll substitute 0 and 1, but we'll also add -1. All right, so 0, when we substitute 0 for x, we'll get 0 to the second power. So when x is 0, we'll have 0 to the second power minus 4, not just -4. Our y coordinate will be -4. Now, when x is 1, we have 1 to the second power minus 4, or 1 minus 4, that gives us -3. When x is -1, so when x is -1, we have -1 squared minus 4, and -1 squared is +1 minus the 4, so we'll get -3 again. So let's plot these points and connect to make our parabola. Make a little bit of space here. connect to make our parabola. All right, so the first point we have is 0, -4. So 0 and then down to -4, plot the point. 1, -3, 1 and then down to -3, should be right here. And then -1, -3, should be right across from the second point. So you see, if you continue to plot points, what will happen, your graph will create this parabola. That should be the graph of functions that have x to the second power. Now for number 23, what is the domain, the range, and is this a function? The domain, remember, is all the x coordinates. So in this case, our x coordinates would be 2, -3, and you don't have to write the 2 twice. So 2 and -3. What is the range? The y coordinates are 9, 6, and 15. Is this a function? Do we have different x coordinates? We have a 2 here and a 2 here. So that means this is not a function. We have the repeating x coordinates. 2 points have the same x coordinate. And that makes it not a function. So 2 points have the same x coordinate. Now for number 24, write the slope-intercept equation of a line that passes through the point 3, -6, whose slope is 2. So we're given m is 2, and it goes through this point 3 for the x coordinate, -7 for the y coordinate. So what are we missing? We're missing the y-intercept. We're missing b. To find b, we're going to use the slope-intercept form of the equation, y equals mx plus b, and we're going to substitute our slope, x, and y into this equation so we can solve for b. When we substitute those values, our y coordinate, instead of y equals, we're substituting -7 for y. Our slope we know is 2, and then our x coordinate right here we'll plug in 3 plus b. So simplify a little bit further, we'll have -7 equals 6 plus b. Let's rewrite it over here. -7 equals 6 plus b. To solve this equation, we'll subtract 6 from both sides of the equation, and we'll get b equals -7 minus 6 is -13. So now that you have your y-intercept and you have the slope from before, we can write the equation of the line. The y equals, our m is 2, so 2 times x, and our y-intercept, our b, is -3, so -13. This will be your equation. And now for problem 25, find the slope-intercept form of the equation that is perpendicular to the y equals -1/3 x plus 7 line, and that cuts through the point 0, 5. Now, by us knowing that our graph or this equation that we're writing is perpendicular to the given equation, we want to find the slope. And to find the slope of a perpendicular line, we're going to take the opposite reciprocal of the slope of the given line. So on this given line, our slope is -1/3. We want to find the opposite reciprocal, meaning our sign is going to be opposite. In this case, the sign is negative, so the perpendicular line will have a positive slope. Reciprocal, we want to flip the fraction, move the denominator to the numerator and the numerator to the denominator. and that becomes 3 over 1. This upside down t means perpendicular. 3 over 1 is the same thing as 3. So our slope is 3. We're moving through the point at 0, 5. So now we need to find b. Just like we did before, we're going to use the slope-intercept form of the equation and then solve for b. So we have y equals mx plus b, and we're substituting 5 for y, so 5 equals, we're substituting our slope, 3, our x coordinate is 0, plus b. 3 times 0, that's just 0. So we'll get b equals 5. Now that we have b, we know our slope is 3, we can write the equation. Y equals 3x plus 5. Oh, I got too many plus signs here. Let's take away one of them. 3x plus 5. All right, 26. In your notes, you're going to have in your notes and in your homework, you'll have a problem about a bird. Make sure you review those and be prepared to discuss them during our class discussion. That's the end of the test 1 review.